13.4 constant velocity problem. So we look at the work example number 8. An object travel at a constant velocity from A to B. So the vector AB is 32I minus 24J meter and the time taken is 4 seconds. So we want to find the velocity. Okay, we know that the velocity is actually the displacement. Okay, the PLACE, displacement over time. So this is 32I minus 24J. And then the time here is 4 seconds. So this one will be the 8I minus 6J. And then the unit is meter per second. Okay, so this is the velocity. So this A to B is the displacement. So this one is the displacement. Displacement is the AB here. Okay, so we have displacement over time. Okay, then we want to find the speed. Speed, we have two methods to find. One is we have the speed equal to the distance over time. The second one is speed equal to the magnitude of the velocity. So for this case, we have the velocity. So for this case, actually, I can use either one to find it. So, but easier if we use the speed equal to the magnitude of velocity, then that is the 8 square plus negative 6 square. And then divide, no, just this is the velocity. Then this one is 10. Okay, so if we want to find the using the other method, so we know that the distance is actually the square root of 32 square. Okay, so the distance is actually the square root of 32 square plus negative 24 square. Okay, so we have the square root of 32 square plus 24 square. Then we have 40. So this is 40. So this will be 40 over 4. Then it is 10 meter per second also. Okay, both will give you the same answer. But this one is easier. Okay, this is more difficult. Okay, we consider a boat sailing with the velocity of 3 negative 2 km per hour. At 12 hour, the boat is at the point A with position vector 3, 13 km relative to the origin. Okay, so we know that when this is the time, okay, so it's 1200, then the times is 0, then the coordinate position vector is actually 3, 13. So after 1 hour, okay, then this one will be 313 plus the 3 negative 2. Then it is 611. Okay. And then when the 2 p.m. time is 2, then we have the 611 plus the 3 negative 2. Then we have the 9, 9. Okay. So we have this one 9, 9 here. And 3 p.m. So we have the 9, 9 plus the 3 negative 2. Then we have the 12, 7. So this is the 12, 7. And then 4 p.m., hour number 4. Then we have the 12, 7 plus the 3 negative 2. And then we have the 15, 5. 15, 5 here. So this one, okay, write the position vector. So the position vector R is actually the 313 plus t in hour of the 3, -2 here. Okay, so for this one, I can use the table in the calculator. We have mode, and then we go to the table, and then the fx is 3 plus 3x. The t I change with the x in calculator, and the gx is 13 minus 2x. So the fx is the x coordinate and the gx is the y coordinate. Then I press equal. I have 0 until 4, and then the step size is 1. So that means from 0 until 4, their gap is 1. So you can see that the 3, 13 here, and then 6, 11, 9, 9, 12, 7, and then 15, 5. Okay, so so this one, this coordinate, can easily get from the calculator. We want to split a velocity into its component. So the velocity of a particle travel not if. Not if is actually we have the NSWE. Not is NSWE. Okay. Not the elephant spread water. So not if is this one. So it's 45 degree here. Okay, and then the velocity, this one, they want to find the velocity, and this is actually the speed. So we want to write as the AI plus BJ. So over here, we know that the cos 45 is the A over 4 square root 2. So A is 4 square root 2 cos 45. And we have the sine 45 is B over 4 square root 2. So B is 4 square root 2 sine 45. So we have 4 and 4 here, if I'm not mistaken. So I have the 4 square root 2 times 8. This one should be 8, not 4. Sine of cos 45. Then I have, wait, this one, the cos 45. Oh, my angle is in the radian, 1 degree. So this is 4. Yes, 4. Why it is 4? Because the cos 45 is 1 over square root 2. So this is 4. So this is 4 square root 2 multiplied with 1 over square root 2. Then it is 4. Okay. So we have the A equal to 4 and the B equal to 4. So the velocity for this, so the velocity will be the 4I plus 4J, and then the unit is meter per second. Okay. The velocity of particle travel on a bearing of 120 degree at 20 meter per second can be written in the form of xi plus yj. So bearing, actually we have this, okay, point to the north. This one point to the north. So the bearing is 120 degree. Okay. Instead of draw like this, I will prefer to draw it this way. So this one, I will prefer to draw it this way. Okay. This is 30 degree here. This is 90 degree. Then this is x. This is y. 90 degree here. Okay. The trigonometry there. Okay. The angle. Okay. The angle that we want is from the x-axis. So 45. The basic angle is 45 degree. And then this the basic angle is 30 degree. So for this one, okay, when we have the SAS, then we use cos. So we have the x equal to 20 cos 30 degree. and then the y will be the 20 sine 30 degree. Okay, so this is 10. Okay, so we have the 20 cos 30, then we have the 10 square root 3, and we have the 20 sine 30, then we have the 10 here. So the velocity here will be the 10 square root 3I plus 10J meter per second. If you don't know how to get the x and y straight, you can do it this way. You know that the cos 30 degree is the x over 20. And then the sine 30 is the y over 20. Okay. Why this happen? Because we know that the Dwaka So. So we have the Dwaka So here. So this one is the opposite. This is the hypotenuse. This is the adjacent. So we have the adjacent and h is ka. So ka here. And then the opposites and hypotenuse is so here. Okay. So this one also we have the 30 degree here. This is the opposite adjacent hypotenuse. So we have the ka here, AH. And then we have the so here, sine. Okay.